a certain sum for any number of periods for a given period of time. Considering a house mortgage, where the mortgage company gives you a sum of money for which you use to buy your house, and then you pay the mortgage company a certain amount every month until the house is paid off. Or consider a savings account where you put in a certain sum of money every month for a year until you're ready to take the money and go out on a vacation. You could use this material to determine whether a bank loan or a lease for office equipment or a vehicle would be a better alternative. You could use it to estimate your retirement. You can use it to put your child through Harvard Medical School, knowing that Harvard costs $30,000 a year at this time, and it is possible to determine what Harvard might cost 18 years in the future. Then you can develop a savings plan such that you will have the money for the medical school when the time comes due. An annuity has 5 elements, any one of which can be computed if the other 4 are known. These elements are 1. Present value or principal, 2. The interest rate per period, 3. The number of periods of the payment, 4. The amount of payment itself, and 5. The future value. Now let's discuss each one of these elements and then discuss some examples. Now let's go across each one of the elements of an annuity in a little bit more detail. An annuity has a value when it starts. For example, a savings account has nothing in it when you begin. This is called the present value. The rate is a rate per period, not the rate per year. If you're doing the calculation in terms of year, then the rate is appropriate. If you're doing it by months, then the rate has to be the rate divided by 12. The same with the number of periods. This simply means the number of periods throughout the entire duration of the annuity. For example, if you buy a house for 15 years, 15 would be the number of periods if you're doing it by year, and 180 if you're doing it by month. The payment is the amount of payment per period, that is by month or per year, and the future value is what this income stream is worth at the end. In the case of a loan, it'll be paid off and the value will be 0. In the case of a savings account, it will be some positive value. The important thing to recognize is that if 4 of these values are known, the 5th can be computed. And note that in finance, all money going away from you is negative, and all money coming to you is considered positive. Now for our first problem, we're going to talk about a house mortgage. We're going to buy the house for $350,000. That's the present value, at an interest rate of 3% per year, which is our rate. We're going to pay it off in 15 years. That's the number of periods. The loan value at the end of the mortgage is $0, which is the future value. The question is, what is the payment? Each of the abbreviations or functions that Excel uses to be able to make the proper computation. Now I'm going to show you how to do it using Excel. As I previously had mentioned, whenever doing any type of problem with Excel or any other spreadsheet, make sure that you use labels. And notice here we've noticed the problem, PV for present value, rate for interest rate per period, the number of periods, the payment, and the future value. Now notice that I've added the values from the previous slide onto the spreadsheet program. The present value is $300,000. The interest rate is 3%, not 3. Some of the residents make the mistake because 3 is 300%, not 3%. The number of periods is 15 years. We don't know the payment, and of course the future value, the house being paid off, is 0. Now in this problem, it's the payment that we don't know. So to make it easy for ourselves, let's color the box so that we know that that is the dependent value. I have previously discussed independent and dependent variables. In this case, payment is the dependent variable. So to mark it, let's just change the color of the cell so that we know where the answer is and what not to change. Now, how do we make the calculation? We go to the formulas. This is a financial function. We look for PMT, which is the function that we talked about. It opens this particular box. Click on the rate box, click on the rate. Click on the number of periods, then the number of periods. Click on PV, and then the future value. And we're finished. And we see that we are going to pay $25,000. Notice the results are in red with parentheses. That means a negative number, which means that the money is going away from you. Now, let's consider it by month. So again, let's label it. The present value equals this. The interest rate per month now equals the interest rate per year divided by 12. The number of periods equals the number of years times 12, which is an asterisk, uppercase 8. The future value is, of course, 0. Now, notice what I did. On the second line, each of the variables depends on what is in the first line, so that I could change the first line with a new problem. Now let's compute the payment per month. Click in the box. We go to Financial. And again, look for Payment. Rate. Rate. Number of periods. Number of periods. Present value. Future value. Then OK. So my payment per month is going to be $2,071 per month for my $300,000 house. Now I want you to understand that the mortgage is not the house. So let's see what the house is worth. The present value, of course, is $300,000. We don't know the rate, but we're going to sell it in 10 years. Now we're adding nothing to the house, so the payment is 0. But we're going to sell the house for $450,000, which is the future value. Notice I've colored the cells which contain dependent variables so that I know not to change them when I'm working through the problems. Now we don't know the interest, so we look for the formulas. Financial, and we look for the formula called rate. Again, we got the box which you had already seen. Number of periods, payment, of course, is 0, present value, future value, okay. Now whenever you see num, that means there is a mistake in the calculation. So we're actually paying $300,000 at the beginning, so instead of $300,000, it's minus $300,000. So my house increased at the value of 4.14% over the period of the 10 years. So you notice that the value of the house increased at 4.14% over the period of 10 years. And notice the house is not the mortgage. Both are independent financial streams. Now let's do another practice problem. I've decided to buy a bass boat. The price at the shop is $11,500. They're going to give me an interest at 6.3% per year with a payoff in 4 years. The question is, how much am I going to have to pay each month for the next 4 years? Now what I want you to do is stop the video, try the problem out, then resume the video to see how you did. Now, if you did the problem right, this is what you'll have. Present value, $11,500, 6.3% interest rate, number of periods 4, so the payment is going to be $3,300 per year. Now, remember, one of the characteristics of a spreadsheet program is if part of the program is identical to another part of the program, you can copy and paste it. For example, we earlier did the mortgage problem. Let's copy it. And paste it. Now we put boat, $11,500, 6.3%, 4 years. So notice that the $3,200 with the compound interest is not the same as the $3,341. Now that I've shown you how to compute payment monthly and yearly, for the remainder of the course we're just going to use annual rates just to make it simple. So there comes a time in your life that you have to buy a car. Unfortunately, I had to buy one because my car got totaled out with the flooding here in Shreveport. So let's talk about the various factors and things that you must consider in the purchase of a car. Now I am going to complicate the problem a little bit and add some additional independent variables to consider during the purchase of a car. To purchase the car, we are going to get a loan. So let's take a look at the independent variables, which are car price, whatever you get for the trade-in, whatever down payment you make, taxes, license, interest rate. The dependent variables are either the number of payments or the amount of the payment. Of these, the only variables that are negotiable with a car dealership are the car price, the trade-in, or possibly the interest rate of the loan. If the car dealership offers you the number of payments or the payment in an effort to reduce the payment, that's just smoke and mirrors. These are calculated values and have nothing to do with what you're actually paying for the car. On the spreadsheet now, we have our various factors that I just talked about. The variables in green are the ones that I have control over or I can negotiate with the car dealership. The price can be negotiable. The interest rate might be negotiable. The down payment is what you choose. Notice it's negative. And then the trade-in value, which again is negotiable depending on the car dealership. Now your real bottom line is what the value of the loan is going to be. And that simply equals of all of the above variables. So that in this case, I would be getting a loan for $44,000. Now let's say I haggle with the dealership and I tell him I can buy a similar car in Dallas for $39,000. He agrees and also agrees to give me $2,000 for my car. So now the value of my loan is $37,000. Now we have the line for computing the payment. The amount of the loan is going to be for $37,000. I converted the interest rate into months, the number of periods for 24 months. The future value, of course, is 0. So the payment per month is going to be $1,600. Now we can do the same thing for different intervals. For example, 36, 42, 48, and 60. Now I've simply copied my 24-month for 4 more periods. Now let's change the period. 36, 42, 48, 60. Notice the longer the time, the lower the payment. This is how the car dealership makes you think you're getting a good deal. If you pay off over 5 years, you're paying only $660, as opposed to, say, $1,000 in 3 years. This is why either the payment or the time period are dependent variables. These are not negotiable. This is why I mentioned that the car dealership might try to snow you with these values, but know where they come from. But the point is, given the amount of the loan, you yourself can choose which time period that you want, and the car dealership will be perfectly agreeable to it. You'll have to forgive a small mistake. The down payment is actually negative $5,000, and the car dealership the trade-in value of $2,000, which is also minus, making the total loan $32,000. And as you see, the corrected monthly payments. Now, let's say I want to open my office and I need an X-ray machine. I go to the X-ray company and they tell me I can purchase a machine for $200,000, or else I can take a lease purchase agreement for $40,000 a year for the next 5 years. Is this a good deal? Or are there other options that I might consider, such as a bank? How do I figure this out? Stop the video, use the material that I've already taught you, and see whether or not you can come up with. Now, using the information that I had already given you, you would come up with this particular value. The present value, $200,000. We don't know the rate. The number of periods is 5. The payment is going to be $60,000 per year. The future value is 0 because at the end of 5 years it'll be paid off. We don't know the rate. How do we do that? We go to Financial and look for the function called Rate. And make sure you're in the right box. Number of periods 5. Payment $60,000. Present value $200,000. Future value 0. Okay. So, in this particular leasing arrangement, you're going to be paying effectively 15.24% per year. Now, you know you can go to the bank and get a lease for 3.5%. So, this gives you the ability to make financial decisions over a period of time. In effect, a lease is like a vacation. You pay for it, and at the end of the vacation, you don't have anything. So we have to use a little bit different type of math. Now, let's look at a car lease. A car lease is unlike the lease above. In the previous lease, we had a machine at the end of the lease period, because that was a lease purchase. This is a lease. At the end of the lease period, you return the car and you have nothing. Let's take a look at the finances for that. The present value equals the $41,000. The number of periods, 36. Payment, $273. And the future value is 0. So let's find out what the rate is. Again, formulas, rate. Bring it where we can see it. So that gives a value of 6% negative. But the important thing is that the rate of your investment depreciates at about 6% per month, or roughly 72% per year. But the point is not the interest itself, but the ability to compare one lease rate with another. Now, to consider how to compare one lease rate with another, the present value you're investing, $3,200, just assume at 5% per year. Number of periods for 36 with a payment of $273. What is our future value? For this, we use the future value function. All right, so this stream of finances means that in 36 months at 5% interest, you would have earned $14,000. Now let's compare another lease from another car dealership. We now go to another car dealership, and they're offering us a 3-year lease with $2,000 down and $325 per month for 36 months. We really don't know what the price of the car is on either car dealership because in both cases they tell us what the lease is going to be. So we can compute the future value of the second lease. We find out that it's $15,000, which is significantly more than the $14,000. So this allows you to compare leases when you have a different down payment, different number of periods, and different payments. My daughter just got her doctorate degree. She comes out of school with a loan amount of $176,000 at an interest rate 6.5%. Unfortunately, this needs to be paid off. However, the time to pay it off is not specified. So I can choose an amount to pay each interval and then determine how long it's going to take me to pay the loan off at that particular rate. Now stop the video and try the problem. So if you have something that looks like this, what we do not know is the number of periods. Again, going to financial, we don't know the number of periods, which is NPER. Click on that. Again, we have our box, rate, payment, present value, future value. Notice that we have num. What that means is that the rate of growth of your loan is faster than you're paying it off. In other words, your loan payment is less than the interest accrued. So let's change the $5,000 to $10,000. Nope, we're still not paying it off. We're going to have to pay more than that every year. Now if we pay $15,000 a year, we will pay it off in 23 years. Or if that's too long a period of time you want to be weighed down with a loan, we could change it to $25,000. In which case your loan will be paid off in approximately 10 years. So this gives you the ability to, given whatever indebtedness you have, to begin to pay it off in a time frame that. Now let's talk about savings. We've talked about loans. Savings is exactly the opposite direction of money flow. For savings, you need a goal. You also need to determine what your time frame is going to be of this savings plan. And finally, where are you going to invest your money? That determines the interest. Now, let's take an example. I wish to send my newborn girl to Harvard University 18 years in the future. I've decided that I'm going to invest in the stock market where historically since 1900 the stock market has been paying about 8.5%. So there's two questions in this particular problem. First, in trying to figure out this particular problem, there are two subproblems. The first is to determine how much Harvard is going to cost 18 years in the future. This is a pure inflation problem, similar to the house problem we did above. Secondly, given the price of Harvard 18 years in the future, multiplying that by 4 gives us the savings goal that we are going to need 18 years in the future. Now, stop the program, try to figure out the program itself, then resume and see a result. Alright, this is the first part of the problem. Harvard University is going to cost me $30,000 per year, so it's negative. The inflation rate we are going to assume is 2.5% per year, and we need 18 years. Now, is there any payment for Harvard's inflation? The answer is no. So the payment is 0. So now we need the future value, that is, how much Harvard is going to cost 18 years in the future. Again, formulas, future value, and of course we have our box as usual, rate, number of periods, payment, and present value. So, this means that Harvard is going to cost me $46,789 per year. So, my savings goal then becomes 4 times that amount, which means 18 years in the future, I am going to need this much amount of money in my account, equals 4 times that. So, the question then becomes, is what am I going to need? This is my savings. Now, currently I have nothing in my account, which is 0. I'm going to invest in the stock market, which since 1900 is 8.5%. Number of periods is 18. What I do not know is my payment. And I know that I'm going to need $187,000. So again, formulas, payment, rate, number of periods, present value, future value. So that means I'm going to have to pay $4,700 per year to my child savings account to reach my goal 18 years in the future. Now, let's say Granddad is so pleased that he is a grandchild that he gives you $50,000 to put in your Harvard account. Where are you going to put it? Is it going to be a payment? Or future value, present value? Now notice that this payment is at the beginning, so that becomes the present value. So, let's put in the $50,000. Oh, now we're going to pay $10,000 per year? This is a mistake commonly made by teaching this class. The point is that grandfather gives you the $50,000. That's positive. However, you reinvest the $50,000, so that becomes negative. So now you see that you have $761 payment. Which direction is that? Notice that it's positive. This means that the money is coming to you, that as a result of grandfather's interest, you are now making $761 above what's needed for the goal. So, for example, let's just reinvest that. This is going to be books and housing. So we're starting out with 0, 8.5% for 18 years. And the payment is going to be this amount of money equals minus this. And the future value is going to be, let's just copy this because it's an identical problem. So you're going to have $29,000 in addition to the $187 for school, books, housing, whatever. Now, let's get into a more complex problem. That is retirement. Here the problem is a little bit more complicated. First, we have to know when we're going to retire. Secondly, we would like to know how much money we are going to need when we retire. So let's assume that right now we're living comfortably on $150,000 per year. How much money am I going to need 35 years in the future to live in the same style? The second part of the problem is I'm going to need this amount of money because I expect to live 20 years. So in 35 years in the future, how much money am I going to have in my retirement program so that I can live in this style for the next 20 years? The first thing I'm going to have to figure out is, given inflation, how much money am I going to need per year? Now, if you did the problem correctly, the first part of the problem would be this. My current cost of living is $150,000 per year. What's my cost of living going to be 35 years in the future? At an inflation rate of 2.5% interest. We don't know the future value. We've shown you how to do it. So, given 35 years in the future to live in the same style, it's going to have to cost me $355,000 per year. Now, the second problem is this. I'm going to put my money into the stock market at 8.5%. I'm going to have to live off it for 20 years. And I want to be paid $355,000 per year. So the question is, how much money am I going to need in my retirement savings account when I'm ready to retire? And it has to pay me $355,000 per year. Equals that amount. And of course, at the end of the 20 years, I'm not going to have anything in my retirement fund. So what I need to know is the present value of this income stream. Now notice the present value is 35 years in the future. Again, formulas, present value, rate, number of periods, payment, future value. So I'm going to need $3.3 million in my retirement fund 35 years in the future. Now the next question is, what if I want a reserve? What if I live longer, or let's say I want to have an inheritance? And let's say this reserve is supposed to be $1 million. Where do I put that? Again, instead of a 0 future value, we have a $1 million future value. Now my retirement goal is $3.5 million, which gives me a residual of $1 million in my savings account at the end of the 20 years. So now I know that I'm going to need $3.5 million in my retirement fund when I'm retired in 35 years. How do I get there? Well, we know that the future value has to be minus this amount because I have to retire at that point. We don't know the payment. Of course, we're going to retire in 35 years at 8.5%. And we're starting out with nothing at this time. So what we do not know is the payment, and again, functions, payment, rate, which you've already done, number of periods, present value, 0, future value. So we know we're going to have to save $18,000 per year for the 35 years until I'm ready to retire. Some financial advisors suggest that in the early part of your retirement you should be aggressive, even though there's more a risk associated with it, because after a period of time the risk should even out. However, they also suggest that during the retirement itself, one should consider very conservative approaches to savings. So in our case, instead of our retirement goal savings at 8.5% for 20 years, let's make it 3%. This changes the retirement goal then to $5.8 million as a result of this conservative approach at the end. And this is something that has to be considered overall, and again, this is where a financial advisor can be convenient. Now, one of the most important things in savings is time makes all the difference. How do I reach my goal? Well, for example, if I invest $1 at the beginning of my 35-year period, when I'm ready to retire, I will have $17 for each dollar I invested. If, on the other hand, I invest $1 for 2 years, I get $1.18 back when I'm ready to retire. So the point is, the earlier you invest your money, the more you're going to earn at the end of the period. Unfortunately, it's at the beginning of the period when you're buying a home, starting a practice, having children, buying a car, and so forth, that makes it very difficult to do any savings initially. Unfortunately, you really have to. Now, let's consider a lifetime savings plan. At the beginning of your practice, as I mentioned, you have a number of problems that you have to deal with. Housing, transportation, setting up a practice, children, etc. So we're going to invest less at the beginning and more at the end, which is exactly opposite of what I explained that you had to do. So from years 1 to 5, we have start out with nothing, but we're going to invest $10,000 per year. So that gives me a $59,000 at the end of the first 5 years. This then becomes the investment for the next period. Equals minus that. Now, the remaining 2 boxes are identical, so we can copy that and paste that. So, if I just invest my $10,000 for the first 5 years and do nothing else, I'll have $684,000 at the end of my 35 years. Well, let's say now in my second phase of my life I can invest $20,000. Now I'm up to $2.2 million. I still have more to invest, so this time we're up to 25. My practice is doing very well. I don't need anything. Now we're up to $3.0 million, almost reaching our goal of 3.5, but not quite. Now at the end of my life I can invest quite a bit. Everything is paid off, my children are through school and everything else. So we can invest, say, $40,000. So I'm above my goal. Now I can play with it a little bit. Let's invest a little bit less at the beginning. Too many zeros. So I'm 3.4, but let's say I can increase this to 30. Now, as you see, I've reached my goal. I've now planned out my entire life, and instead of doing this by 10-year periods, you could do it every year, and as the year completes, you could actually put the real value as opposed to the estimated value for that particular period. And as the years go on, you know where you are with regard to the goal that you set out at the beginning. The question is, what now? Now that you have decided what you're going to do with your money, the next problem is to decide where to put your money. It is at this point where a financial advisor would be helpful. Although I've laid out the basic plans for a retirement plan, you still have tax implications which can be quite complicated. I believe that I have outlined financial problems sufficiently so that you can have a well-balanced, intelligent conversation with a plan. Obviously, for retirement purposes, you are going to use some form of income tax deferred plan. One, consider investing in the stock market. On the average, the Dow Jones has grown about 8.5% per year since 1900, despite the Great Depression and the recent stock downturn. You can invest in the stock itself, but then you have to pay attention to what your stock is doing all of the time. Some financial people said that 1 stock out of 10 does extremely well, 1 out of 10 extremely badly, and the other 8 average. But you are a doctor, not a financial person, and it's likely that you have no interest in picking stocks. The stock market is something like the 2 billion lottery a few months ago. Someone is going to win the 2 billion, but almost certainly you will not. Another option are mutual funds. In this case, you pick a company you feel is going to be a good investment and has a good reputation, and you give them all of your money. There are a few problems with this particular approach. The mutual fund may charge you to get into the fund and charge you to get out of the fund as well as charging you additional fees during the time they're managing your account. And this can be a substantial fraction of the gain of the stock within this fund. In November 2015, the New York Times had an article about mutual funds. They looked back 5 years and picked the 50 highest paying funds. Then they looked at the same funds recently and found that out of these 50, only 3 were still in the highest 10%. And they predicted that in 1 year that none would be. A third option are index funds. The management fee is quite low. These funds are linked to a specific index in the stock market, such as the Dow Jones. They track the activity of this index, and you can be assured that you will not lose nor gain any more than the particular index will. If you want diversification, you can buy into such funds as the Dow Jones, Far Eastern Industry, or European banking, for example. Another retirement alternative are annuity companies. These are basically insurance companies which pay you a certain amount every month at the time you're ready to retire, instead of when you die. After your initial decision, only minimal involvement is required. The best you can hope for is that the company is still in existence when you're ready to retire. If you or a family member is really knowledgeable about some other area, such as real estate or the oil business, and that person has the time and energy to manage that particular option, then this would be an area where you could consider investing. The most important thing to remember is that everything related to finance depends on a series of assumptions. There is an assumption that the financial markets are going to have a constant rate of growth over the next 35 years. It assumes that the inflation rate is going to be relatively constant. ISIS could nuke New York City, in which case any financial growth would be inhibited well into the future. You make your best guess, you go with it, and you continually revise your financial plan as time goes on.